To find the condition for common roots in two quadratic equation, we first consider the equation say a1x square plus b1x plus c1 equal to 0. This is the first of the equation. And another quadratic equation is a2x square plus b2x plus c2 equal to 0. This is the second equation. In first equation, a1 is not equal to 0. In second equation, a2 is not equal to 0. Then first we will find the condition that both roots are common in these two quadratic equations. If both roots are common, then the roots are alpha 1 and beta 1 for the equation 1, and their sum is minus b1 by a, and their product is alpha 1 beta 1 equal to c1 by a1. Similarly, in equation 2, the sum of the roots is alpha 2 plus beta 2, that is equal to minus b2 by a2, and alpha 2 into beta 2, this is the product of roots, and it will be equal to c2 by a2. Because it is given that both roots are common, that means alpha 1 is equal to alpha 2 and beta 1 equal to beta 2. This implies that the sum must be equal, that means minus b1 by a1 will be equal to minus b2 by a2. Similarly, product must also equal, that is c1 by a1 will be equal to c2 by a2. We can write these equations as a1 by a2 equal to b1 by b2, and another one as a1 by a2 equal to c1 by c2. So on combining, we will have a1 by a2 equal to b1 by b2 equal to c1 by c2. This is a condition for the both roots common in the two quadratic equations. Now we have to find the condition for the one common root in two quadratic equations, which are given by a1 x square plus b1x plus c1 equal to 0. Another equation is a2x square plus b2x plus c2 equal to 0. And suppose alpha is common root. So this common root will satisfy both the equations. So we can write a1 alpha square plus b1 alpha plus c1 equal to 0. This is the equation number 1. And another is a2 alpha square plus b2 alpha plus c2 equal to 0. Now from the equation 1 and 2, we arrange the terms to use the Cramer's rule to find the condition. The terms are alpha square alpha and 1, and coefficients are a1, b1, c1. For second equation, coefficients are a2, b2, c2. So we can write that alpha square by cancelling the first row and first column, we will remain with the four terms. This is b1, c1, b2, c2, and we have to take the determinant of these four terms. It will be equal to minus alpha. Here it is minus 1 raised to power 1 plus 1 because it is the first row, first column. In this, it is minus 1 first row and second column, so it will be minus divided by the cancelling the first row and second column. The remaining terms are a1, a2 and c1, c2. It is equal to 1 by, here it is the minus 1 raised to the power first row and third column, so it will be positive. And after cancelling the first row and third column, we will remain with a1, a2 and b1, b2. Using the determinant value, we will have alpha square divided by b1, c2 minus b2, c1. First we multiply diagonals element, then subtract the another product. It will be equal to minus alpha divided by a1, c2 minus a2, c1, and it will be equal to 1 by a1, b2 minus a2, b1. This implies that using the first and third, we will have alpha square is equal to b1, c2 minus b2, c1 divided by a1, b2 minus a2, b1. Similarly, alpha will be equal to, using the second and third term, we will have minus of a1, c2 minus a2, c1 divided by a1, b2 minus a2, b1. Or further we can write it as a2, c1 minus a1, c2 divided by A1 B2 minus A2 B1. So this implies that alpha square is equal to B1 C2 minus B2 C1 divided by A1 B2 minus A2 B1 using the first and the third term. Similarly, using the second and the third term, we will have alpha is equal to A2 C1 minus A1 C2 divided by A1 B2 minus A2 B1 after adjusting the minus. So we put the value of alpha. Here we will get A2 C1 minus A1 C2 divided by A1 B2 minus A2 B1 whole square. It is equal to B1 C2 minus B2 C1 divided by A1 B2 minus A2 B1. So it will be equal to A2 C1 minus A1 C2 square. It is equal to B1 C2 minus B2 C1 into A1 B2 minus A2 B1 square divided by A1 B2 minus A2 B1. This one term will get cancelled. So finally we get the condition that A2 C1 minus A1 C2 whole square, it is equal to B1 C2 minus B2 C1 into A1 B2 minus A2 B1. This is the condition that one of the root is common in the two quadratic equation.